Course 1, do you ever have it where you got a huge fraction like 125 over 1,000 and you're supposed to see if you can simplify or reduce it to avoid that half credit marked wrong? But you just wonder, what would that be? I don't want to go through all the work of finding out, besides if it comes out even as a whole number, which you can do with a calculator. Reducing can be a lot of work when the numbers are big. And that can be frustrating to figure it out if you don't have a good divisibility test. In this case that 5 and 0 do, but even then, you have to just divide both by 5, and you might have to divide even further. What if I told you that there was a way to reduce fractions with large terms by combining this skill, which you've seen before, and the factor tree, prime factorization skill that we've learned? Put those two together now, and you can reduce something like 125 over 1,000 fairly easily. First, factor down to its smallest Lego blocks. I believe 25 times 5 is 125. 5 is already prime. We're getting good at that. I can break 25 into 2 more 5s. Meanwhile, there's 1,000, which easy is 100 times 10 because there's 3 zeros. 10 can be broken into that 5 again, as well as the 2 are both prime. And then I've got 2 more 10s that I can already tell are going to do the same thing. Right? So I always, when I prime factorize, I list 1,000 is in order 2 times 2 times 2 times 5 times 5 times 5, I think. Dot, 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 dot. 1, 2, 3, 4. Got all my factors. Good. And 125 was easy. 5 times 5 times 5. Now if I put this on top of this, I can use now my canceling skill that I learned. Maybe I'll cheat a little and I can already see that these match up. So I'll line it up to the right here, and then I cancel the pieces, the individual prime pieces. And that means I've just got, there's always a 1 here, over 2 times 2 times 2, or 2 cubed. It comes to 1/8. So 125 over 1,000 we found with some simple factor trees and canceling of those prime factorization lists to get to a nice reduced fraction. And I think that's pretty cool. And you can do that with any large factors, any large terms, I should say, for a fraction, whether it's 375 and 1,000, 875 and 1,000, or let's just try 36 over 81, and then I'll let you pick 2 other ones that we haven't done. 36 over 81. A little bit smaller numbers, not factors, or not multiples of 5 or 0 this time. Of 5, I should say. 36 over 81 are my terms, the numerator and the denominator. So we break up 36 into, maybe you could do this without the factor tree, 6 times 6 is 2 times 3 times 2 times 3. Check it on your calculator. You've put those 3 as those 4 terms, 4 factors together, they will multiply out to 36. They're just the smallest possible pieces that spell out 36. So I put them in order, least to greatest, right? And then I've got 81. 81 I know is 9 times 9 from my multiplication tables. And 9 is, of course, always 3 squared. So I've got 3 factors down here. Now let's do that canceling. I can get rid of these 2 that line up, because these are multiplied factors you can cancel. They're not being added or subtracted. You can cancel out when they're factors being multiplied. Why can't I cancel here or here? Because these are different factors, and I can't cancel here because they're both in the same term. So I've got 2 times 2 over 3 times 3. Can I reduce that? Nope. It's going to be as far as it can be if I did all of this stuff properly. So 36 over 81 is 4/9. Why don't you Try A, B, C, try 2 of those and show me the work.